Bright Tuty. Every student matters.
Hi dear students, I am Amit Ajmani and today we will be taking up the next topic, that is acceleration. Now, till now in this chapter we have studied about the object moving with a uniform speed or a non-uniform speed, the distance travelled by the object, the displacement of the object, right? Now, if an object is travelling along a straight road or a straight path, right, and the speed of the object is uniform, there is no change in it, right. So, therefore, there is no change in its speed or velocity. But if, let us say, an object is not moving on a straight road, or an object or a vehicle is moving with non-uniform motion in a crowded place where there is a lot of traffic or congestion. So, over there the speed or velocity of this particular object is going to change, and this gives us a new physical quantity which we call as acceleration or acceleration, the way you want to pronounce it, right, acceleration or acceleration. Now, what exactly is acceleration? Acceleration is the rate of change in velocity. Now, we know that when we talk about velocity, we have two varieties or types of velocities, that is initial velocity of the object as well as the final velocity. First of all, let us be acquainted with what exactly these initial and final velocities are. Initial velocity means the speed or the velocity which the object was initially moving, right, and this is represented by small u, whereas final velocity is the speed or the velocity with which the object is moving after a specified time when we observe it. It is represented by small alphabet v. Fine. And when we talk about change in velocity, that simply means change in velocity can be expressed as final velocity minus initial velocity. Whenever we are talking about a change in a particular thing, we say that what was the initial value, what is the final value, and the difference between them is the change, right. And I have already told, I am repeating it, whenever it comes rate of simply means per unit time. Per means divided by. So, that means whenever we are talking about rate of, it simply means you have to divide it with time. So, now when I am talking about the definition of acceleration, I can mathematically express it as rate of means divided by time taken. Change in velocity is final velocity minus initial velocity. So, when I am talking about acceleration is equal to change in velocity per unit time, or change in velocity divided by time, or final velocity minus initial velocity divided by time. This acceleration is represented by small a. Final velocity, as we have studied right 2 minutes back, small v representation. Initial velocity is represented by small u, and time is represented by small t. So, this is the mathematical representation or the formula for acceleration, right. This is quite important. Now, when we are talking about velocities, we know that the SI unit of velocity, whether it is initial velocity or it is final velocity, the SI unit is meter per second, and of course, we know the SI unit of time is second. So, meter per second gives us meter per second square. This is the SI unit of acceleration. Quite important 1 marker question. What is the SI unit of acceleration? It is meter per second square. It may also be expressed as meter per second square, or we can also write it to be meter second minus 2. Minus 2 because this 2 power, it is in denominator. When it comes in the numerator, we know that it is converted into negative power. So, whether we write like this, putting a slash, or dividing it by second square, or we are writing second minus 2, or inverse, we call it inverse power. So, this is one or the same thing. This is the SI unit of acceleration, right? Fine. Now, there are a few things that we need to relate. Acceleration we have understood, right? That acceleration is the rate of change in velocity of an object. Now, when an object is moving in uniform motion, that means the initial velocity and the final velocity is same. Initially also, let us take an example, the body is moving at a speed of say 15 kilometers per hour. Again, continuously it is going with the same speed of 15 kilometer per hour, and again with the speed of 15 kilometer per hour. The initial velocity with which it was moving and the final velocity with which it is moving, it is all together the same, and it is moving in a straight line. So, there are two conditions. One is the body should be moving in straight path. Another is if the body is in uniform motion, then we related and saw that the change in velocity is 0. The change in velocity will be 0, and if we say acceleration is final velocity minus initial velocity divided by time taken, this is change in velocity. If this is 0, that means the acceleration of the body is also 0. Fine. So, the body is not accelerating, the body is not showing any acceleration motion. Fine. Next, let us see, if there is a non-uniform motion, then we say that the change in velocity is not 0. That means there are now two options that we will relate. What are the two options? Let us see. Let us take an example that a body initially is moving at a speed of say first part is 50 kilometers per hour. We will relate it as the initial velocity, that is represented by small u. After let us say 10 seconds or 5 seconds time, we again calculated its velocity represented by v, or the final velocity. Now, there are three options. First option that we have already discussed, that the velocity is same 50 kilometers per hour. The second option is maybe the velocity is increasing, the car is speeding up. Let us say now the velocity is 60 kilometers per hour, right. The first case that we had taken was the velocity remains the same, that is 50 kilometers per hour. The second case we are taking is that the velocity now is 60 kilometers per hour. But there is another possibility. That possibility is that maybe because of some traffic, because of any traffic signal, or because of any reason, this particular car applies brakes and it slows down. And if it slows down, then in that case, now its final velocity, let us say, decreases, and it is less than what initially it was travelling at, right. So, there are three options. Let us assume all the three options. We say that acceleration is change in velocity upon time, or v minus u upon t. Got it? If our initial velocity is 50 and the final velocity is also 50 regardless of the time, the acceleration becomes 0, right. This is what we have already studied. Let us see the second and the important case. The second case is कि now acceleration is final velocity is 60 kilometers per hour minus initial velocity was less, that is 50 kilometers per hour in whatever time. So now we have got acceleration is 10, which is positive value. Why it is positive? Because the final velocity is more than that of the initial velocity. So when the value of acceleration comes out to be positive, and when it will come? When the final velocity will be greater than the initial velocity, then we call it a normal acceleration, or we also call it positive acceleration, or in other terms, in layman terms, in normal day to day term, we say that the object is speeding up, right? The speed is increasing. Fine. Now quite importantly, let us take the third possibility, that our initial velocity u is 50, that is the u, and the final velocity is 30 kilometers per hour in whatever time, 2 seconds, 5 seconds, whatever, right? Now because the final velocity is less and the initial velocity is more, our acceleration comes out to be minus 20 upon t. This minus sign represents that the final velocity is less than the initial velocity, or other way of saying it is that the initial velocity now is more than that of the final velocity. And when this is the case, then initially in the second case we had said that it was positive acceleration or simply acceleration, but when the value of acceleration is coming out to be negative, then we call it a negative acceleration, or we give it another name, and that another name is retardation. So what is retardation? Retardation is simply negative acceleration, and retardation is simply minus a, or other way around, when a is in minus any value. The SI unit is same, everything is same, meter per second square, simply there is a minus sign, simply it represents that the initial velocity was more and the final velocity was less. And when will it happen? It will always happen whenever there is some opposite force is acting. That opposite force is maybe due to the wind, when for example we are paddling a bicycle. After paddling 10 or 20 times, if I leave paddling and the air is going opposite to me, then that air, that will create an opposite force and it will tend me to slow down. Or when we stop paddling, the tires which are basically in contact with the road or the surface, that surface, when two surface combine or they are in contact with each other, we know that there is an opposing force, that is force of friction, that also slows us down. Or whenever brakes are applied, when you apply brakes, then also the speed is going to slow down. So in all the cases, the final velocity will be less than the initial velocity, and hence it will be negative acceleration, and it is also known as retardation. Got it? So these are the two things you need to relate. First thing, acceleration is positive acceleration, it is understood. That means the car or the object or the vehicle is speeding up with respect to time. Second is negative acceleration or retardation, that now the speed of the car or the object is comparatively slower than what it initially was. Got it? It should be other way around also. If acceleration is given to us, for example, in any particular numerical that we will encounter later, it will be that acceleration is 2 meter per second square. So, we will simply say a is equal to 2 meter per second square, but if it is given in the question that a car is retarding at the rate of 2 meter per second square, right? When retarded word is given, that means now I have to take the same 2 meter per second square but with a minus sign. This is quite important that you need to relate. Got it? Fine. Now, regardless of whether this particular object is accelerating or retarding, the rate at which we are observing this object or the vehicle to accelerate or retard, basis on that rate, this acceleration is also of two types. One is uniform acceleration and another is non-uniform acceleration, right? Or similarly uniform retardation and non-uniform retardation. Whenever we are talking about the word uniform, that means there is a consistency, there is a symmetry, right? For example, a car A was traveling at a speed of 10 meter per second, right? Initially, after 5 seconds, I observed the speeds and it was 15 meter per second. After another 5 seconds, when I observed, it was 20 meter per second speed. After another 5 seconds, it was 25 meter per second speed. After, let us say 5 seconds, it was 30 meter per second speed. So now, after every interval of 5 seconds, the speed of the car is increasing, and that increase is in a symmetrical manner. That is, every time it is increasing at the speed of 5 meter per second, 5 meter per second, and so on. Got it? So this kind of speeding up, right, accelerating uniformly is termed as uniform acceleration. Had it been the initial speed is 10 meter per second, after 5 seconds, it was at the end of 5 seconds when I noticed first. After 5 seconds, it is 12 meter per second. After another 5 seconds, it was 20 meter per second. After another 5 seconds, it was 36 meter per second, and so on. So now the speed is increasing, no doubt. From 10 it has been 12 and then 20 and 36, but there is no symmetry actually. There is no consistency. Such kinds of acceleration, speeding up, are known as non-uniform acceleration. Got it? The same term, uniform and non-uniform, we can relate with retardation. Taking the opposite example of it, that initially the speed was 30, after 5 seconds it was 25, then 20, then 15, then 10. Putting arrows this way. So this is, the speed is getting slower, the vehicle is slowing down and consistently in a uniform way, so that will be uniform retardation. And similarly, if we are talking about 36, then 20, then 12, then 10, then it will be a non-uniform retardation. Got it? Fine. Now, acceleration, retardation, uniform acceleration, uniform retardation, this all we have studied. We need to relate a few things. What? We have seen that the formula for acceleration is v minus u upon t. We will be given a few numericals or questions based on this particular formula, but for attempting them, we need to relate these three very important concepts. What are these concepts? You have to remember, because they will be applied throughout the chapter now in all the numericals. First concept is, whenever a body starts from rest or from a stationary position, means whenever the body is not in motion and now it is at a state of rest, from there it will start moving, then obviously we will say that the initial velocity of this object is 0, because initially it was not moving, initially it was at a state of rest, it was stationary. So whenever in a question it is given that a body starts from rest or simply starts, that means it is understood that we have to take the value of u to be 0, that is the initial velocity is 0. Got it? Second concept, a body is normally moving at a particular speed. So the speed at which the body is moving is its initial velocity or initial speed, to say that, right? If this moving object or a body stops, if it stops by applying brakes, that means the final velocity of this object is to be taken as 0. So whenever a moving body stops, that means the final velocity is 0, and this is what we need to relate in the question. What exactly is the language given in the question? If we are said that a body starts from rest and gains a velocity of whatever, so that means a body is starting, we need to take initial velocity to be 0. If we are said in the question, that we will see of course, but just try to relate. If we are said that a body which is moving at a speed of 10 meter per second, right, stops by applying brakes. Stops means the final velocity of the body is assumed, is taken to be 0. Got it? And whenever u is equal to v, this is the third concept. That means a body is moving with a constant speed, a constant velocity. Initial velocity and final velocity both are same. In that case, we say that now the acceleration is 0, because the body is neither accelerating nor retarding. The body is not increasing its speed, the body is not decreasing its speed. In that case, the acceleration of the body is taken to be 0. So these are a few things that we need to relate. Along with of course the very important fundamental, if the initial velocity is more, if the brakes are applied, then in that case it will be a negative acceleration. So whichever value is given to us in the question, that means it is to be taken in with a minus sign.